All right, it is now time for my absolute favorite application of matrices, and this is their applications to cryptology. Cryptology is the science of encoding and decoding secret messages. So when you hear that, you often think about spies and government secrets and whatever. But in reality, we use cryptology all the time. We use encrypted messages all the time because anytime you say, order something from Amazon, you put your credit card in there. You do not want your credit card number just like flying around, through the internet. So it's encrypted. Okay, it's encoded so that when it gets sent over the internet, it is not just your credit card number. And then when it arrives at its destination, the computer software has to decode it so they have your actual credit card number. So tons and tons of stuff is encoded and decoded with cryptology science. It's a really, really important field of mathematics right now. So I want to show you a real simple one. I don't know if you've ever seen these like in newspapers. They're called cryptograms, and they're just secret messages where every letter has been replaced by a different letter. So it's a nice encoding device. It works. The problem is if you know enough about the English language, it's pretty easy to solve this. For example, see, I've got that apostrophe right here. So I'm pretty sure that's an S. Okay, there's not that many letters that we use an apostrophe with. I'm going to go so far to say that this first letter is its. So then that means that this over here is probably the word to, T-O. And using this, I can start figuring out. So like I said, it only takes a little bit of knowledge of the English language to start figuring this out. Like often there's a lot of words that are TH, so I might guess that that's an H. And now this 3-letter word here looks like how. So you just kind of keep working through this. I have an I right here. I'm going to guess that that's ING. And then I would just keep working through this. I'm actually pretty good at solving these cryptograms because I do them a lot and I know the English language well. So the problem with this is that every time the letter T is encoded, it's encoded to the letter S. And every time I is encoded, it's encoded to the letter X. And that makes the cipher easy to break. What we would like is something that maps different letters to different things. Okay, that would be a stronger encoding. And so matrices provide us a way to do that. So what we can do is we can encode a matrix. We can encode with a matrix, and then we decode it with its inverse. And if you don't know the encoding matrix, it's really hard to decode the message. So here's an example for number 7. Let's say you wanted to send the message, meet me Friday. So the first thing we're going to do is break up the message, meet me Friday, into letters. And I'm just going to do it, numbers, corresponding to their position in the alphabet. So M, let's see. M is 13, I believe. Is it the 13th letter? There's A, B, C, D, E, F, G, H, I, J, K, L, M. Yeah, but it's the 13th letter. So this message becomes 13, 5, 5. T would be the 20th letter. And then M again is 13, and then 5, and then it's going to go on. I'm not going to do Friday. Okay. Now, I don't want to send this string of numbers because this would be pretty easy to decode, again, just knowing the English language. So let's say my friend and I have decided on this matrix A that we're going to use to encode stuff. Now, since it's a 3x3 matrix, I need to break my message up into chunks of 3, okay, like that. And then what I'm going to do is multiply each of these matrices by my encoding matrix. So I'm going to take this first one, 13, 5, 5, and I'm going to multiply it by matrix A. 1, negative 1, 0, 1, 0, negative 1, 6, negative 2, negative 3. Okay, this is a 1x3 matrix. This is a 3x3 matrix, so we can multiply them, and the answer is going to be a 1x3. So it's going to look like this. All right, let's get some different colors here. So to do this, we're going to take row 1 by column 1. And I'm suddenly wishing I had a calculator. So that's 13 plus 5. That's 18 plus 30. So that's 48. And then row 1 by column 2, that gives me negative 13 plus 0 plus negative 10. So negative 23. And then row 1 by column 3, 0, negative 5, and negative 15. So negative 20. Okay, so the first part of the message that I send to my friend is 48, negative 23, 20. And then I would do that with the next matrix. I would take this matrix and multiply it by A, and that would give me my next string of numbers. Okay, so this is going to send my message. And what's so great about this is, remember, my original message, M, E, E, both of the E's were 5s. Now when I send M, E, E, they're different numbers. So this is a really, really hard code to break. And then when my friend gets it, they are going to multiply it by the inverse. So I'm not going to do this problem all the way out, but let me show you number 8. So then your friend gets the message and they send this back to you. So now to decode this, you're going to do the same thing. You're going to break it into chunks of 3, and you're going to take those numbers and you're going to multiply it by the inverse of A. Now, we would need to use our Desmos to find out what the inverse of matrix A was in the last problem. And when you multiply it back, that's going to give you the original string of numbers, which you can convert back to letters. So matrices are a much stronger encoding device because, like I said, it makes different letters map to different numbers. It is not what is used. We use a lot more sophisticated encoding devices on your phones and that kind of things. But this is just a real basic introduction to it that I wanted you to see because cryptology is kind of cool.